take a look at. Today we take a look at vertical stretching and shrinking. So if you have g of x is equal to a times f of x. So now instead of adding something or subtracting something, we're going to multiply by a. Is a on the outside or inside? So is that going to impact it vertically or horizontally? Vertically, yeah. So it's a vertical stretch. By a factor of a. And that's if a is greater than 1. What do you think happens if a is less than 1? Yeah, or a shrink. Yeah. So we'll say vertical compression by a factor of a if a is less than 1. Okay. Very good with that? All right, so suppose we have g of x, and that's equal to f of bx. What's different about that situation? B is on the inside, so that's going to impact it horizontally, okay? And in this situation, this is a horizontal compression. By a factor of 1 over b. That's if b is greater than 1. So, you know, the best way to try to understand why that is what it is to consider this. If you had, say, y is equal to the square root of x plus 4, that's a horizontal shift, right? But is it right 4 or is it left 4? Everybody agree that this is left 4? It's opposite of what you think. Also happens with the horizontal compressions and stretches. If you see b in front and it's greater than 1, you're like, oh, well, that must stretch it horizontally. It compresses it by the reciprocal. Okay? So the best way to think about this is first take the reciprocal. If the reciprocal is smaller than 1, then it's going to compress it. If the reciprocal is greater than 1, then it's going to stretch it. Okay? So horizontal stretch by factor of 1 over b, and that's if b is less than 1. So it's kind of opposite of what you think. It's not really important that you know that extremely well. It is going to come up in a couple small cases, but as we move forward, it's not quite as important as the others. Okay, so I want to use the space above that a little bit. Can I erase that? Is it okay if I erase that now? Okay, so all the functions that we've discussed can really be written in the form that you see below. So, for example, I could have y is equal to negative 2 times the absolute value of 2x plus 6 minus 8, okay? And we could graph that. Now, you know the shape of an absolute value function. What's the shape of an absolute value function? Yeah, very good. Yeah, that was good. Now, I told you earlier that eventually you're going to have to learn how to graph y is equal to, say, negative 3 sine of, say, 2x minus pi over 2 plus 1. And this is actually the highest scoring test of the year when you learn how to graph that. I know it looks super complicated now, right? But it doesn't look quite as complicated as when we first started, because you're like, well, I get what the 1 does. That just shifts it up 1. And I get the negative out front. That's going to flip it, and then the 3 is going to stretch it. So all of a sudden you see all the different things. You might be confused about the inside. It's really not that big of a deal, but you know, at the end of the day, you're just wondering, well, what does sine look like? Like I know what the absolute value function looks like. It's really not that big of a deal. So you'll get it really well. So let's just kind of compare what we have here to this guy. So you see the minus 8 in place of the d. What does d do to a function? This is a review of all the pieces we've talked about. Good. Vertical shift. So that's an easy one to identify right away, okay? You see that thing on the end there, added, it's a vertical shift. What is A going to do to the function? What's A going to do? Yeah, vertical stretch. What happens if A is positive or if A is negative? What A is positive, A is negative, what's going to happen? Yeah, if A is positive, it's going to be right, the graph's going to be right side up, agreed? Where if A is negative, it's going to be a vertical flip, it's going to be upside down. So I'm going to draw, my smart board's getting really upset with me. So it's going to be right side up, whereas if A is negative, it's going to be upside down. Okay with that? Okay, and then we have this multiplier on the inside. If we see something multiplied on the inside, what does the B value do again? Creates a, yep, horizontal compression. Remember, if B is positive, it's going to tend towards the right, where if B is negative, it's going to tend towards the left. It's going to reflect it horizontally. And then finally, this C value, I want to be clear about this. As you look at this whole piece right there, horizontal shift, what we do is we solve Bx minus C is equal to 0. Now that's a little bit different than what we've talked about before, but I just want to be clear that when you start putting a number in front here, you could factor that 2x plus 6. I'm just going to look at that part. You could factor be 2 times x plus 3. So if you factor like that, what's the shift going to be? Left 3. Everybody see that? So the other way to think about it is if you just take that and solve, 2x plus 6 is equal to 0. 2x equals negative 6, x equal to negative 3. That tells you it's a shift to the left 3. See that? And actually, if you saw, if you see like x plus 3, you just solve x plus 3 is equal to 0 and subtract 3, x is negative 3. So if you just think about solving for 0, it's going to tell you which direction you're going. We all good? Okay, excellent. All right, so in order to do then this example, so let's put it together and try something. So I've got 1 here and I've got 3 there. I want you to just copy down the shape. And this is a table that kind of matches with those coordinates that I plotted. So I've just selected a variety of points. Very good. Okay, so we're going to call this function right here f of x, and it's not that interesting of a function. It's just kind of a, I don't know, just a little shape with 4 points. But we're going to transform it, okay? And what we're going to do to transform it is we're going to come up with 4 new points, okay? And we're going to sketch those coordinates. So what I want to do is instead of graphing f of x, I want to graph 2 times f of x. Very important you focus on the language that we're using here. Is it 2 on the outside or inside? So that's going to impact it vertically. So that's going to create a vertical stretch, agreed? So if it's going to stretch vertically, does that change the x values? No. Does it change the y values? Yes. So as I make a new chart, I'm going to write it right here, and I'm going to leave the x values alone. -2, 0, 1, and 3. I'm going to leave those alone because this 2 does not impact those at all. What it does is it impacts the y values. What do you think I do to the y values? Yeah, I multiply by 2. I get 0, 4, 4, and 0. Now, if I've done this correctly, and I'm only going to do this in this situation, because this graph is bigger than this graph, I'm going to put this shape right on this spot here. I'm sorry if you, my smart board did not like when it shut down, it kind of reset. It got off target. Somebody like really jealous that I get to do this right now. You're like, I want to come up and try that.
Oh, yeah.
If you run on up, I'll give you the marker and you can have your fun.
For real?
Yeah, for real. Do it, Sophie. Do it and you're cool. Okay. Yeah, if you mess up, it's going to be bad. There she goes. She got nice. Okay, excellent. Let's see if we're back on track. We got -2, 0. Nice. And then I had 0, 2. I had 1, 2. And I had 3, 0. Well, let's see. Well, 1, 2, 3. It's right there.
We have to plot the original.
No, you don't have to. I'm just doing this so you guys can see the scale of what I'm doing. Okay, so now I'm going to do the new one. Back 2 up 0. So that's the same spot. Then 0, 4. Then 1, 4. And then 3, 0. Does it look like the same shape, just stretched twice as much as it used to be? Good, so we know we did it correct. Let's look at the next one, okay? And Sophie, you had kind of a little bit of question here, which I'm guessing a lot of people do. We're going to make sure we get this correct here. But what do you notice about the inside? So what's that going to do to it? The question is, it can make it bigger or smaller. 0.5 is the same as what? 1/2. So if it's on the inside, take the reciprocal. What's the reciprocal? 2. So is that going to make it bigger or smaller? Bigger. So this is going to create a horizontal stretch by a factor of 2. So is that going to change the x values or the y values? The x. So we're going to take all the x values and we're going to multiply them by 2. So you can see how you do the opposite. You don't multiply by 0.5, you multiply by 2. So we get -4, we get 0, 2, and 6. And then the y values in this situation, does anything happen to the y values? Why? Why do we add 1? The +1 means you have a vertical shift up 1. So that's going to impact the y values. So the y values would change to 1, 3, 3, and 1. So when I plot this, I should see it wider and shifted up 1. So -4, +1, 0, +3, 2, +3, and 6, 1. Does it look wider than the red one? Is it shifted up 1? Yeah, so we did pretty good there. Let's look at the next one. Got my x, y. Now, you have to perform these in the order of operations. So if you were to plug something in for x, you would first subtract 1, then function operation, then multiply by -1, then subtract 3. So you have to do it in order of operation. What does an x minus 1 do? Move it to the right 3. Is that going to change the x values or y values? X values. If we move it to the right 3, what are we going to do to the x values?
Right 1. We're moving to the right. Add 3. But you're going 1, not 2. Yeah, down to add.
So I'm focused on the -1. Right 1 is going to add 1. See how it's opposite what you think on the inside? So because I'm moving right 1, we're going to take all these and add 1. So I get -1, I get +1, I get +2, I get +4. Now this negative sits on the outside. That's going to affect the y values. Okay? So what used to be up at +2 would flip down to be -2, correct? So that means we're going to flip all the y values, and after we flip them, we're then going to subtract 3 because it shifted down 3. So if you make 0 opposite, it's still 0, and subtract 3, we get -3. If we take 2 and flip it, we get -2. Subtract 3, we get -5. 2, flip it, we get -2. Subtract 3, we get -5. Flip 0, we get 0. Subtract 3, we get -3. So let's check that out. Back 1, down 3. Over 1, down 5. Over 2, down 5. Over 4, down 3. I should see the same shape. It should just be flipped, shifted to the right, and shifted down 3. And sure enough, it looks exactly like that. Any questions on that one? So our last example for the day. XY. What do you notice first? 2 on the outside. X is negative. 2 on the other side. What do we need to deal with first? We got to deal with the order of operations, so we always deal with the inside first, okay? This inside first. What's the negative going to do to it? Reflect horizontally. So does that change the x values or y values? So we're going to take all these x values, we're going to multiply by -1. So I get positive 2, I get 0, I get -1, and I get -3. So we see on the outside times 2 and plus 2. Do I multiply them by 2 and add 2, or do I add 2 and then multiply by 2? Which one do I do? Good. Order of operations, I multiply by 2, then add 2. So 0 times 2 is still 0, plus 2 is 2. 2 times 2 is 4, plus 2 is 6. 2 times 2 is 4, plus 2 is 6. And 0 times 2 is still 0, plus 2 is 2. So I'll plot those. And it should look like the red one, but it should be stretched, which it is. It should be flipped, so instead of heading off to the right, it should head off to the left, which it is. And it should be shifted up 2, which it is. So I know I've done it correctly. Okay, go ahead, take out your assignments. Let me show you what this looks like. And you're actually going to get a lot done today in class, so long as you use your work time wisely. Okay, so as you look at this first part, notice how it says, suppose the graph of f is given. Describe how the graph of each function can be obtained from the graph of f. Here's all you want to do, okay? What does the -3 do to the function? So you just have to write down 3. That's it. That's it. So for letter B, what would you do? Write 3. That's all I'm looking for. Is everybody okay with that? Okay, please flip it over to the next page. For problem number 2 here, okay, it's referring to this function. It says function f is given. This actually says g, so it's function f. But you know, in our example, remember how I had that set of coordinates off to the right-hand side? Go ahead and make an XY table here right now. Make XY table. And we're going to put 4 points on our XY table. What do you think should be our first point? 0, 1. And then 1, 2. And 4, -1. So, folks, real quick here, I just want to go with like the corners of the graph. So this one, this one, this one, and that one. That's all I want to do. So, yep, so we got 0, 1, 1, 2, 4, -1, and 6, 0. So if you don't want to sketch the graph, the new graph, you don't have to. But under each of these, make sure that you list the new table values and what they would be. Okay. If you look to the next side, that's what we do tomorrow. Okay. So the third page of this is what we do tomorrow. We actually are going to be looking at what we refer to as odd and even functions, which shouldn't be very difficult. It should go pretty quick for you. But that's probably because you're really intelligent. We good? Got lots of time to work, folks.